business. Personally, it gives me great happiness in introducing our next speaker to you, Mr. Sidharth Rajeev. Sidharth holds master's degree in computer science and engineering. He is a TEDx speaker and he gave a TEDx talk on his own invention, 7 Sense technology in Jan 2015. He has got an experience of almost 10 years working with data consultancy services on different domains and platforms. His IoT journey started from early 2015, which involved IoT design and architecture for several domains. Working, he is currently working as an external IoT architect and consultant for Cargotech Finland from 2017. His main focus is on IoT device management and connectivity. Sidharth is currently positioned as an IoT connectivity architect at Kone Corporation, Finland. Kone is a global leader in manufacturing lifts, escalators, and automatic doors, and he is now joining us from Finland. Ladies and gentlemen, presenting to you Mr. Sidharth Rajeev. I wholeheartedly welcome you, Sidharth, to this FDP. Over to you.
Thank you, ma'am. Thank you, ma'am, for the wonderful introduction. So, good afternoon, everyone. I hope everyone can hear me. Am I audible?
Yes, Sidharth, please go on.
Sure. I will share my screen. Wait a second. Are you able to see my screen?
Yeah, it's yes.
Okay.
Yes,
So, thank you, ma'am. So, today my topic is basically on IoT in Industrial 4.0, and already my introduction was be done. So currently I'm working as an IoT connectivity architect with the Kone Corporation, Finland, and like before I was also into the IoT, like I was working as an IoT architect with Tata Consultant Services Limited, and I was positioned as an external architect for Cargotech Finland for almost 4 years now. And my IoT journey started from 2015. So that's my IoT experience. And yeah, I work in different domains like manufacturing, then utilities, then into the energy department and HVAC systems. So different domains I have worked, like almost I have worked with 9 to 10 domains, industry domains as well, right now into a product company. So where we are a global developers on lift, cranes, and elevators and automatic doors. So that's the introduction. So first of all, let's start with what is Industry 4.0. So basically, it's a fourth revolution of, we can say the fourth revolution. So what is actually that? I hope like I can just give a glimpse, like first generation is a textile industry revolution, and second revolution was more on the electricity side, and third one is called the digitalization, where the automation of the things like computer came into picture and automation of the things happening. So what is this fourth revolution? So fourth revolution means like how these computer devices, or the like the device that automates itself, like one of the job it can do, so how it can communicate with other devices, or how the like the devices, different devices can communicate each other, and how this data can be processed, how artificial intelligence or machine learning can be applied on the data, and how to process it, and giving it instructions back to the devices and do things automatically. So that's how, like, then the world is actually connected. Right now we have like smart TV, smart home, smart, all are smart. That smart means like we have some sensors to collect the data or to analyze the data, how it is working. So some sensors are for reading the temperature, humidity, and those kind of things. So externally it is collecting the data. Some sensors are for analyzing how the device is working. Suppose our car, smart car, like nowadays the cars automatically starts and all those things, right? It can also, we can remotely see that or how it is performing when I want to do a maintenance. So these kind of things, like where the immense potential is there. So right now we are in an era of industry 4.0. And moving to the next one, what is IoT and how it is related to this industrial 4.0, how it is enabling this industrial 4.0. So Internet of Things is termed as IoT. It means like in the description itself, like Internet of Things, it's a connectivity of things. Things means that can be a devices, it can be a car, it can be a mobile, it can be a laptop, it can be a gateway, it can be your like any kind of electronic legacy systems, or which have some sensors to collect data, or some of the cases where some of the legacy systems. Legacy means some of the systems that is already in use. If you take the example where current my industry is like lift technology, so where the lift earlier lift having some motor based like manufacture, where it actually uses a pulley to push up pull and pull down the lifts, right? So where how we can put the additional sensors there to collect the data, like to monitor that how the lift moves up and down, and how much efficient it can be, and what are the use cases, inline use cases we can provide to the users. So that's one specific area I'm saying. So this can be applied to any other specific area, like if you take a biochemical reactor, or e-commerce like Amazon Go. If you go and you have a smart e-commerce system where you can just go take a trolley and go and take the food items, and you can just go out of the shop. So you don't have to wait in a queue, or you don't have to pay at all. It is automatically done. So these things are the applications that is enabled by IoT, and the IoT helps to connect all these devices, and thus it actually enables the industry 4.0. So industry 4.0 is kind of combination of IoT, automation, AI, these kind of technologies, like disruptive technologies, I can say. This kind of disruptive technologies made this possible. So IoT takes a large portion of that. In IoT itself, there are different kind of areas. Like I can say, like in IoT, like there are expertise in edge. Edge means the end devices or the things. Things means like the devices in the field, in the maybe if you take a farming technology, there also we will have some sensors to predict the temperature, humidity, and those kind of parameters. So that gateways or that devices that we deploy on the field, or that actually does the function, that's the edge part. And how that edge part connects with other devices, that protocols, so that comes under the connectivity, or how it connects to the cloud. So that's also will come under the connectivity part. And the cloud means we need to suppose it's like 10 devices or 20 devices, we can, even if we are sending a messages in per millisecond, it won't be a huge task to check that things. But how we can scale up to millions of devices and collect this all information from different devices, like from a smart TV, smart home, like different devices. We have smart devices and smart sensors as well. So how we can gather all this data, how we will know that, okay, which are the relevant data to process further in the cloud. Those aspects of big data, and how the processing, parallel processing, and how to mission critical, if some for the mission critical problems, we need to alert it back at the same time. So how to process that. So those kind of things happens in the cloud. So that's the cloud part of IoT. And then on top of, once we have the we have two kind of data. One is the cold data, and one is the hot data. So cold data is something that can be processed at a later stage, and basically does like artificial intelligence will be based on that. Like we will train the data models on top of that data, cold data. The hot data is something that we will put some thresholds and see that, okay, if something is happening, we need to do something like some maintenance, or some part needs to be replaced. So that is called the hot data that we will process at this like at the earliest, and will revert back or do some actions based on that. The cold data is something on top of that. That's the historical data. On top of that, we will build our models. Models will be created with the mathematical equations, or like based on the probabilities and statistics. Those kind of the areas are being used for modeling. So that's what actually does in the artificial side, intelligence side. And then with that models, we can push the same models also to the edge devices, so that it will be more intelligent, so it can take an action in the edge itself. It doesn't have to connect to the cloud to take an action on that. So that's the cloud part of that. And the analytics part is also there. So that's the third part, we can say. Once we have the data, we need to do this kind of modeling on top of that, with the understanding of the domain. So for analytics, mainly we need to understand what's the domain, what are the parameters, what are the, like if a airline, I have worked with the airline fleet management. So for a Switzerland based company, where we need to take the, okay, how the flights flew, and how the flaps go down, and how we need to monitor everything. Like it's a life risk factor, right? So we need to monitor, and we need to know, understand every domain, every bit and pieces of that. And so that with that we can model it, and we can be sure that, okay, because of these parameters, there may be 1,000 parameters, and we need to analyze that, okay, what's the correlation between each of these parameters. So that's comes under, I'm not going into deep of that. So that's come under the analytics part. And then comes the visualization part. So it may be a different visualization part for a user. A user may be having a mobile phone. It may be a user, maybe if I own a like aircraft, or a, like in any different condition, like if I own a, like two different lifts, and maybe I have a like residence area, and I own the lifts over there. So I want to know that, okay, what's the status of that, all the lifts. Maybe a user in that like flat needs to only, and like to get only the accessibility to the lift. So that user interface is also a part of that, like a different user interface, one for the domain expertise, one for the owner, one for the user. So how we can give a good user interface for each of the users. So till now, any questions do you have? Or like if you have any questions, you can put it in the chat box, and we can take it in the end also. Is it clear till now?
Yes, Sidharth, go ahead. We'll have the question at the end. Okay.
Sure. And if it is too speed also, you can tell me, like if I need to bit slow down, I can slow it down as well. So going into the main protocols, like what are the standard protocols like industry use in different cases. Like we have different IoT communication protocols. Like communication protocol examples I have given here is like MQTT, QoAP, HTTPS, WebSocket. So basically in industry, we mainly use a TCP and UDP based protocols. Like where UDP is used, like we want to make a faster response, then we will use UDP. Otherwise, if you want to maintain a session with that, like we use a TCP base. So basically MQTT, HTTPS and WebSocket are TCP based, and QoAP is a UDP based protocol. So where we use these kind of protocols, and how to determine that, okay, I need to use a TCP or UDP. That's actually the architecture or design decision that we will use. Also we need to understand, okay, we cannot run a heavyweight protocol in the edge. Like if you take a consider example, like if you consider a Raspberry Pi or something, it has more capabilities, but it may not be that feasible for every devices in the edge. So where we need to have a lightweight protocol that can that is built on TCP, and then we can have a session maintained with the cloud. So basically the MQTT is the main one you will be hearing in IoT world currently, and HTTPS will be the first protocol. Like how a device can commission to like commissioning is the word that is mainly used in the IoT world, where how the device will be commissioned and provisioned. So means suppose we take an example of a smart TV or a smart TV where it needs to update the firmware inside. There is a firmware running inside the each device. So if it is TV, then that firmware, how it can be updated to and how it can be connected and how it can be securely connected. So this process is like a series of tasks. Like first it will be like if a new device comes out of the factory, and once it is connected to the internet, it will connect to the cloud, where most of the common practice is like it will be connecting through HTTPS call, and with that it will get a certificates. So it's based on X.5.9 certificates, and that will have the credentials for connecting to the next server that will be having the MQTT. That's basically used like a free open source servers. I can name something is like EMQT server, and then there are some other paid versions are also there. AMQP is there, RabbitMQ is there. So there are open source varieties, and also there is PaaS kind of varieties are there. Like what like PaaS means like it's like a kind of services that provides like by Amazon, Microsoft. So they have the cloud based all application already there. So we have to pay according to how you use that. But if you want to try it out free, then there are a lot of things like free open source MQTT brokers are available. EMQTT is one of that. So you can cluster it up. So vertically and horizontally, we can scale it up as well according to the load that is coming up. And we will have like elastic load balancers in front. So if you take considering like millions of devices connecting to a server, then we need to have a elastic load balancer in front. So that's how the architecture will make for that if we want to scale it up. So, and currently the use of WebSocket is also being used like to show the real time, like what is happening, real time, what the graphs and all are based on WebSockets. And it's also based on TCP, where we just focus on like whatever the push to some port number, then that like the data will be read at the same point in time. And if you consider the legacy systems, I told like we need to also consider we cannot replace everything, right? So we need to coexist like the old, the new, and the existing ones, every devices in a single platform, right? So the current systems, like if you check like the car, we have CAN bus. So most of the car we are taking the data through a CAN bus protocol. And if you see the backnet, so that is another protocol that is being used in mostly in SFAC systems. So SFAC system is nothing but it's ACs, whatever you use, Voltas or like different companies use this kind of backnet protocol. And OPC UA is a marine technology, so mainly that is used in the ships and all. So these are the like standard protocols that they use to talk with different devices inside the like if you take a example of OPC UA, the ship may have different devices. It have like data recorder, it may have different sensors. So how these will talk with each other, that is basically on a same language. So that is basically is called OPC UA. That standard is basically OPC UA. So that there's a standard that everyone will follow. So different vendors, there will be different customers manufacturing the ships, right? So they may have different sensors built on that. So how these can talk to each other? So there needs to be a standard. So this is how I will talk to this machine. So there is like an example. For example, if you take the example of Mac and Windows, how a Mac can talk to Windows, or how these can talk together, like that's the same way. So there we will talk about like OSI Pi model and all, how through the internet how these machines can talk each other. So that's why we study like in our engineering like classes what's the importance of OSI Pi layer. So how the data will transmit to the internet and will come back, how it will be processed. So that's the standard that we'll adhere to. The same way here in the industry side, the CAN, Modbus, BACnet, and OPC US are the main protocol, and how these protocols can talk to MQTT or COAP or HTTPS, and thus it can reach to the cloud. The data can reach to the cloud. So that's the main industrial focus on how we can do this kind of things. Like right now, there are like drivers for open source drivers for converting the OPC UA like parameters to MQTT parameters, and then it can be sent to the cloud. So that's how it is fully connected. So that's how the system will be connected from the end device to the cloud. So there are like different moving to the next slide. There are different kind of system designs and architecture. How we know that, okay, and that I need to use this client server architecture, or whether I need to use a master slave architecture, or event driven peer-to-peer publish subscribe architecture. I hope you may have heard this kind of architectures, and we have been through all these architectures from years back, right? So suppose we take the example of client server architecture, like where the client and there will be a one server base, right? So this kind of architecture is mainly used in the legacy systems and even the master slave architecture. These are the two. So if you take the example of BACnet, OPC UA, and Modbus and all, they use this kind of master slave architecture where the one master is there and slaves are attached to that, and then the master queries and get like we can get all the details on the master, like we can query from the master and get the details. So there are like different implementation on top of this, like C++ libraries available for this, and we can query the like even for Canvas and Modbus. If you search in the GitHub, you will get the libraries. That's that. Basically, this what's architecture done on backend is like the master slave architecture or client server architecture. And moving to the cloud, there mainly we are using the event driven architecture or the publish subscriber architecture. Like event driven architecture is mainly used in, if you check the current architectures that may be used mainly in the WhatsApp or in Twitter. So you use this kind of architecture. It's a combination of architecture. It's not like one architecture we will use. It's a combination of architectures that we can use in the cloud or in the edge side. So that depends on the requirement, how you need to do that. Whether I need to use a Redis in the cloud, so in memory, whether I have a use case where I need to fetch everything more frequently, then I can use Redis there in the cloud. So or whether I need to have a queue in the cloud, or whether I need to have a MQTT broker in the cloud. So these all depends on the how you want to process the data. Like if you take the case of event driven architecture, like one example is AWS Lambda. It's basically based on that. So that means if you give a trigger, it do a function on top of that. Like if you're saying like, okay, I got this message from a queue or from a MQTT broker, I need to do this kind of action on top of that. So that there it's built on event driven architecture. So moving to peer-to-peer, it could be like in the case of IoT, there is like modems, like 4G modems or 5G modems. So if you take example of 5G, there the peer-to-peer architecture has been implemented, where repeaters are there within 10 meters. Then it transfers the data from each repeater to next repeater. So that's how it maintains the frequency. So basically, going to the 5G, it's like we are going to the spectrum of like wavelengths, how much wavelength and frequency, and because of that, we need repeaters to modulate it up. So there we will use this peer-to-peer architecture. So this kind of same scenario we will use in the cloud scenario as well, where we need to see that, okay, if we want to connect with the different and we want to have the metadata in every server, we will have this peer-to-peer architecture. Publisher subscriber architecture is mainly used in the Kinesis. If you take example of Amazon Kinesis or MQTT broker connection with Mosquito, we will have this kind of pub subs architecture. Pub sub means a publisher will be there, a subscriber will be there, and a broker will be there in between. So the broker will have the messages sent with if a publisher is sending some data to a topic, so there's a topic, so that topic will be subscribed. If someone is subscribing to that topic, they can listen to that, whatever the messages that is being pushed to that topic, specific topic. So that's how the publish subscriber mechanism works. And this is one of the major architecture that is implemented in most of the IoT devices, where we want to send to a certain topic, and from where we need to take all these things. So I can even make a hierarchy of topics. Like I can say that, okay, I need to send from Finland, this area, this specific region. I need to collect all the data in a single server, or in a single region, or a single like shard or something like that. So for that, I need to have this kind of publish subscriber architecture. So these are the different architectures that is being used most heavily, and it is a combination of all these things. It's not like I will only use client server architecture. No, it's like kind of, I may have master slave architecture in the cloud for Mosquito Broker. I may have a master slave architecture for elastic load balancing. So and inside that, I may have event driven architecture for processing data. So if you take a like example of Ola, Caps, or WhatsApp, or there are different combination of services, right? If you take a example of WhatsApp, it's not like messaging, it's like group messaging, how I need to handle the group messaging, how I need to handle the video call. So all these are different kind of architectures clubbed together, but all perform their own action. So these are the from looking from IoT perspective, these are the main architectures that's been used, and it is a mix and match of all this. But there are other architectures as well, but I just took the main architectures that has been used. And so like from thinking from a layman perspective, like how, like if you want to develop something, so I need to create this servers and huge servers, MQTT server, and I need to spend a lot of money for that and maintaining these things, right? So that's very hard to do that from current scenario. So it's very easier to use the AWS or Azure or Google cloud platforms, so that even there is a free subscriptions there if you want to try it out. But if you want to use, then they will charge for that. Like if you want to send millions of messages, then that's for a business perspective, then they will charge for that. But if you want use is free, yes, there is like a lot of services already there, that is like past services there for the each sector. Like for checking into the IoT side, there is AWS IoT Core is there, AWS IoT device management is there, then Mosquito Broker is there. So all the services are already there. You need to just commission devices on that, and you can use that the same things on Azure as well, on also on the Google cloud platform. So these are the cloud ways you can use directly, and you can even do a IoT project maybe within 2 weeks time. You can have like if you want to monitor the temperature or humidity, you can, maybe if you are more expert, you can do in maybe in 3 or 4 days you can finish out everything. So that's how easier now. So you have all the components ready in your hand, and you don't have to pay if you are not using that much for a business purpose. Then it's easier to develop and easier to do the things. Even there is like in AWS, there is a like service called AWS SageMaker that actually have inbuilt algorithms and inbuilt modelings, like linear regression, logistic regressions models are already there. So you can use that to model. So you don't have to develop for that as well. You can develop on top of that, like what is extra things you need to do, or what are the lacking functionalities that you can implement on top of that. But general infrastructure is already been done by these cloud providers that we can directly use and test it out. So how these cloud services are like maintaining that, okay, the security is maintained, or like from a if you are taking away the cloud providers, and if you want to do it by yourself also, you want to make sure that, okay, what is the current industry standard and what is the best practices there. So the best practice is like using the certificate based encryptions and certificate based channel encryption. So data encryption is also there, channel encryption is there. So channel means like if you want to connect a TCP, like if you take example of HTTPS call, we will use a certificate so to connect to the cloud, and then with that certificate the channel is actually encrypted, so nobody can, a third party can, like a hacker cannot enter into that channel. If he able to enter into the channel, it will be encrypted, he cannot actually decrypt it back. So it needs like supercomputers for doing that, so that's not feasible at all. So uh, that's a channel encryption. So how about data encryption? We can use again, so basically we use like key based encryptions are there, but that is not that good for the security perspective. We use again certificate for encrypting the data as well. So how there are questions comes in the security aspects, like how we can store these certificates in the device. So in the device also there is called a trusted TPM module. So that is a module that we cannot access even if we get into the Unix systems or in the Linux based systems. Inside, if you get into that, if you have a TPM module, we can store the data there, but we cannot read the data whatever you are storing there. So you can use that, you cannot read or edit there. So that's how we need to store the certificates or keys or configurations in those TPM modules. So that's a standard, industry standards to have TPM module. The latest TPM module is TPM 11, and that is a standard provided by IBM. So the libraries are also be available open source, and you can even use that. Even our OS will support that, Linux OS will support that. And the basically we are using the TLS based certificate authentication, and certificate based encryption. So that is the main standard that we'll use, and how to enroll that, and how to if some device is compromised, it should not like every device should have its own unique certificate. It should not be common for every devices. In that case, it is very vulnerable. If one hacker is able to hack one of the device, and it will allow him to get into all the devices because it's all connected, right? So we can easily jump into each of the servers, and we can even hack the bank servers, and everything can be possible on that if you make a one of the devices compromised. So that should not happen. So in that case, we need to have different certificate for different devices. So the provisioning mechanism should like whenever the device connects to the cloud, it should have a mechanism to like in the cloud to have a different certificate generator for each of the devices. So the certificates, how to generate our own certificate, you already know, there is putty generator can also create your own certificate, like or OpenSSL keygen, you can generate your own certificate. So certificate will be having a private certificate, key, CA, and public certificate. Private will be stored in your server, and public can be given to anyone. So with that, they can connect to whoever you want to connect to your server. You can give that public certificate. So that's how it. If you want to try it out to yourself, that's a way to go for that. And basically for testing out the security and all, you will have to know the Linux basics commands, and you need to work with the Linux based systems. That will be more better. Then you will understand how it works and what are the like SHA 512 or 256 or RSA, what kind of algorithm you encryption algorithm you want to do, and those kind of things. You can take a decision on top of that. And moving to the IoT in business domains. So these are the main domains I have worked currently. So there are different n number of business domains that are being used by IoT now. So it's a era of IoT, I can say, where everything is connected to internet, and this is kind of a disruptive technology, and day by day each technology is coming up. It's not like tomorrow there will be new technology, and we need to adapt to that. There are different platforms coming up, there are different languages coming up. So if you check, like earlier it was C++, Java, now it is like Python, R, or Scala, Go, Golang. So different language is also coming up. So it's like we need to adapt to each of these languages, or and only thing is that we should be thorough in our basic understanding of how the TCP works, how the UDP works, how the architecture, how the base architectures work. So this if you have this understanding, we can also cope up with any of the new technologies that is coming up. It's all built on top of that. So it's like building a foundation, you are building floors on top of that. That's only the thing. So in IoT in different business domains, I can take the example of e-commerce. So here the example of Amazon Go. So that is been even implemented in India also. So in most of the American companies having this kind of smart shopping market. So if you I can take an example, like if you want to go to Lulu Mall, then in Kochi, like if there is like a huge queue there, right? So for paying the bills and all. So if that is if that can be converted to smart shopping, then you can just take a scroller and then get into the shop and get the items, and you can just move out, and automatically your bank will be linked to that, and then the purchase will be made. You don't have to wait for the queue, or it's a hassle free. So it makes the user more comfortable and very easy to move on. Like the time is more precious for everyone, right? So in that case, this is a kind of e-commerce application IoT, where we use like different, I can tell about the different edge devices used, and that is like beacons, RFID. So these are the scanners and the load sensors. These are the things that will be used in the edge scenario of that e-commerce, where we will track how we will track like which are the items that the user has already purchased and all those things. And more complex ones are like using the video streaming or image processing also, we can use that things. So this is the the sensors, or how we collect the data, and then on the cloud we will process the data, and accordingly we can see that okay, how much is the price, and what are the things that the customer has been taken from the shop. For next one, I can take the airline industry, where it is been mainly used to predict the maintenance. Like predictive maintenance is a term. So that's a main thing that is be used in most of the industries, even in manufacturing or utilities and energy. Predictive maintenance is a main thing. Like if I am a I am a product owner, and I am producing some of my products, right? So that products may be owned by different customers, and that customers may have different uses as well, right? So that's a current scenario. So in that case, as a producer of that product, I need to know that okay, I need to serve my customers very effectively. So for that, this predictive maintenance is more important. So by predictive maintenance, I need to handle like okay, when to do a service, or when a part of a machine will fail. I can predict it. If it is not used correctly, then I can inform the user that okay, because of this product, this part of the product can fail in this many days. Or with that, actually the business won't stop there. If you take an example of a cargo industry, where if a cargo handler crane is damaged, then it actually stops the ships over there, and the port fees will be increased. So the customer, from the customer person, he's losing the money there. So that should not happen. So that's a seamless flow. For maintaining a seamless flow, we need to have this kind of predictive maintenance on top of that, on each of the part of the machine. Like maybe a motor will be there, maybe a hydraulic machine will be there. So how it is performing, is it very good, is it like performing good in the different scenarios. Like it's also climate also can affect the working of each of the components. So in here Finland, if I take an example, here the temperature can go down to -30. So how that will affect some of the working of the car. Like if you want to switch on the car, it may not start automatically, because of this the temperature. So how effective we can do that, or how it can heat in itself. So those kind of artificial intelligence can made by this IoT, enabling IoT. So that's the main thing in airline, manufacturing, and utilities and energy. Utilities and energy basically having like windmill and all, like in Australia and all, they're using this for the heavily using IoT for maintaining that, to predict the how much efficient it should be, when to switch off the AC, when to switch on the AC, and according to the number of persons in a area, how to effectively make the AC adjustments. So those kind of things are smart, making the devices more smart. And these are the technology, IoT is the main technology used on top of that to enable that. So if you take the example of manufacturing, I can take an example of like cargo industry, where the cranes can be manufactured. So cranes have thousands of parameters there. So how we can collect all this data? So it may have different kind of protocols, and may have to have a gateway there, dedicated gateway there. So there are different gateway manufacturers there. So gateway doesn't mean like like a whole thing out, like it's just a device that can have that is running a Linux OS. So it just collects the data, and we can run our own our own programs or softwares or firmwares on that device. So that's actually a device that connects to the cloud. So if the manufacturer doesn't have a capabilities to connect direct to the cloud, we can have a additional gateway attached to that product, and it can communicate to the cloud. So that's how we can enable the connectivity between the device and the cloud. So that's an example for manufacturing industry. And also there is a car manufacturing also. We currently the BMW or Mercedes or Audi or those kind of car manufacturers are into the smart world. So we can operate the car with using your mobile phone and all. So that's how the technology goes fast, and we need to cope up with that, and how better we can produce the things. So that's the current area of interest, and current studies are also happening there. Even in the current WWDC, like the Apple conference, already the Apple CEO has mentioned that there are plans for connecting with the BMW and Ford with your phone. So you can actually get into the car using the phone. So that's an IoT use case, where you're connecting with via MQTT and connecting to the CAN, and then then starting the car, or using starting the engine, or those kind of things are done very easily. So basically you need to understand the domain properly, how the domain works. So then we can there is possibilities to connect to that domains, like each of the part of the engine or any device you can connect, and you can do the things at your will. So that's beauty of this IoT, actually, we can say. And healthcare and insurance is the other sector, where healthcare you can directly remotely connect to each person's health and do a remote operation, or that kind of robotic operations can be also done by using IoT, where it can give impulse back. How, like if there is some kind of surgery needs to done, then it can also the remote doctor can actually do some actions on top of that. Like he can, or he or she can give instructions, or it can automatically even identify, like a human, it can identify that okay, what needs to be done next. So that's a case of a artificial intelligence there. And also insurance, some like insurance domain, if I take an example, is like in the US and all, there are two kind of insurance domains, and they're mainly used using IoT. One is the car insurance, that's mainly comes under telematics domain. So where if a driver, they will try to see that okay, driver is driving the car very smoothly, or he's doing like he's driving rashly. How it can be found out with is using the accelerometer. One of the cases, accelerometer, it can actually see that okay, how much movement it is made, and how much harsh brakes has been done. So with that, actually they will reduce the or increase the insurance for that insurance premium for that customer. So they will try to drive smoothly the car, like that makes a more better environment for everyone. So that kind of one of the instance. And the second instance is the hailstorm. Like there are hailstorms in like that can damage the rooftop. So that's kind of one of the other instance like area that they're trying with the IoT. And other things are the like smart home, smart city. These all things are like application of IoT, and these are different kind of domains, I can say, that is being used by IoT. And future and scope of IoT. I hope by this time you will understand, like there are different scopes there. There are endless scopes for IoT. You can connect everything in the world, and it's even if it is a mobile phone or your gadgets or any other device, it's all can talk to each other, and it's like an endless scope. Like it's a start of a like era, I can say. It's going to move faster. It's a technological disruption, I can say, and more jobs and more opportunities. And there is a scope on in IoT. There is scope in each sector. It's like in a security, it maybe in a edge device, or in a cloud device, cloud area, or in analytics, or in artificial intelligence. All these are combined together in IoT. So every area has specific research scopes, and more advancements can be done. So it's not like the end, like if you take the certificate based authentication is at the end of the thing. No, it's not that. It will be much improved with more algorithms on top of that, more complex algorithms, because there will be a kind of supercomputers that can crack all these things. So we will come up with new things on top of that. How we can make it more simpler, how we can connect all the devices more simpler. So these are the things that will have us research scopes and patent scopes as well. And so the references, I can say, like some references is like more documentation if you need on each specific things. There are a lot of documentation available in AWS and Azure. Documentation is there, and new technologies, platform, language awareness must, I can say. What I can show is like, so here if you see, this is a AWS documentation. If you see, there is like a lot of compute, container storage, database, how these things are done, or how you can use that. This has already been done. And security, cryptography, machine learning, and how you manage like all this chatbot, CloudTrail, and logs. How can you do that? All this documentation is pretty good here in AWS and Azure, so you can do that. And just like to give a glimpse of how the technology is being used in one of our use case in my product company right now. So I can just show that. So this is something that is used right now, right? So like you don't have to touch anywhere, you need to touchless. And this kind of COVID scenario, you need to have this kind of things to be there. So this is something that is already been done, and this is just they thought and they have done, they're being in the market. So that's a speed right now. We can think about something and you can do that. So another one also, I can show one more video on one more application of Kone.
Elevators, escalators. Kone cares. Kone goes touch-free. Kone has always stood by our customers in both good and challenging times, coming up with innovative and world-class solutions to make people flow smoother, safer, and more convenient. Today, in a world where touch has become risky, we at Kone have gone one step ahead to bring a touch-free solution through your smartphones. A Kone touch-free lift is just a WhatsApp away. Send out a WhatsApp message to the assigned number to call your lift. You will be directed to the nearest available lift. Walk in and find your registered destination floor without touching buttons. Walk out as the doors open. As simple as that. The all-new elevator remote call feature using WhatsApp for your safety, health, and well-being. Kone Elevator Call. Kone, dedicated to people flow.
So that's how these are like Kone is actually a global leader in the European market and in worldwide. Actually, I can say like there's other standing in the second in the world right now. So yeah, that's why like the new things, if it comes earlier, then that will be taken by the market. So yeah, with that note, I can end this one. Like thanks for like hearing to me till this time, and but we can have the questions now, and this is my like personal contact. Like if you want to have like any questions regarding IoT or anything, yeah, this is my LinkedIn profile and this is my WhatsApp and email address.
Thank you, Sidharth. Now we will have the Q&A session. If anybody is having any queries for Sidharth, you can post it in the chat. Okay. We have one question, Sidharth. What is required to become an IoT engineer?
Okay. So basically, from my understanding, when I started to I started into the IoT journey in 2015. So what I actually started with is I didn't have that much capability in doing in Unix or Linux system. So basic Linux or Unix system understanding is must for an IoT engineer. Then there is endless capability. Like you will understand how the things works even in the OS level. But you don't have to that much. Like you don't have to go that deep. But you need to have basic understanding of the Linux system, and then the basic thing is like you need to try out the things using a Raspberry Pi. You just try to collect the temperature sensor or your humidity sensor and just read the data and collect it to the cloud and do some processing. So then you will get a whole view of ideas of how the things works. Then you can go into deep like, okay, how these things actually work in behind. So that's a knowledge that you will get, and then you will be an IoT engineer in the going forward. So that's my experience from that. Does it answer your query?
I hope he has answered your question. Do we have any other questions?
Anything you can go ahead. There's nothing like a stupid question or something. Every question is valid, and we need to learn anything new. Every that will be very good for.
You can also unmute your mic and ask your question directly to Sidharth.
Hi, Sidharth. My name is Matthew. I am from Rajagiri School of Engineering and Technology.
Hi.
I'm not working in IoT. I'm basically in software engineering.
Mm-hmm.
I had this basic doubt from the beginning.
Mm-hmm.
IoT, the full form is Internet of Things, right?
Mm-hmm. Yes.
But if we can connect a sensor wirelessly to a local server, we don't need and get the data and display it in a mobile app. That is possible, right? Without the internet, is it?
if you want to connect a, I didn't get that question. If you want to
can
get
even
a,
connect the sensors in
Mhm,
the sensors to a local server
mhm,
wirelessly and
mhm,
get the data and
mhm,
process the data and display it in a mobile app without
mhm.
going to the internet or the cloud server, right?
Yeah, that is also a part of Internet of Things because you are using their wireless technology, right? But
Yeah,
you are
but
not.
I'm not connecting to internet or I am not using cloud server.
No.
Then there is no involvement of internet. So
Yes.
can you really call that application as an IoT application?
Yes, definitely. Yes, it is an IoT application itself. But it's like what I told earlier, like different architectures or different implementation can be done, right? So if you need a fast computation or fast diagnosis, we don't need a cloud itself, right? You can do that things in the edge itself. But in that edge itself, if you're connecting to different devices, yes, then there is an internet of connectivity. Then you are talking to different devices, you are talking to mobile, and you are connecting from a sensor, and you are reading the data, and you are wirelessly transmitting some local server. So that's the internet of things itself.
Okay, thank you.
Okay, thank you, Siddharth. One more question is there.
Mhm.
Please say something about the public key cryptographic algorithms used for IoT security, also the vulnerabilities in it.
Yeah, sure. So that's a good question. So public key, basically how the security works here is like, if you take an example, uh, in the cloud there will be a device name A, and A has we will create the keys certificate, private key and public key in the cloud. So that's in our part, right? The cloud is in our part, or a server that's in our control, right? So we will have that in our private server. We will have a so that has a kind of like private key, public key. Okay, this public key can be transmitted to the device, so that needs to be also transmit that can be transmitted using encrypted channel. So for that encrypted channel, how we will have that encrypted channel? So the device will have pre-installed CA certificate. So that's the factory certificate. We'll say that factory certificate in industry standard. That's a factory certificate. So once a device is out into the market, it will definitely have a certificate, CA certificate, already residing in its TPM module. With that, it connects to the cloud, and with that, it will have the new certificates loaded from the cloud to the device. So how the device connect to the cloud? It will connect using this certificate, the unique ID, and then it will call a HTTPS. Suppose it's a calling HTTPS call, then it is connecting to that server with using this CA certificate and saying that, okay, hi, I am this device A connecting. Please give me the certificate. So then we will identify that, okay, this device has this certificate, and that is for that certificate. That certificate has this kind of details of that device as well. So then it will push this public certificate to that device, and using that public certificate, it uses the next message channel. So the MQTT channel will be using that public certificate to encrypt the channel, and also it will may have one more key for encrypting the data. So that encryption is being done using this certificate, and then the data will be encrypted as well. And then it will be sent to the cloud, and cloud will have the corresponding private certificate to decrypt it. So currently the standard is X.509 certificate, and we use for the data encryption and data channel encryption as well. So what I can say that currently that's the best one. But earlier some of the IoT devices are using the key shared key concepts. So that is not that good, because no, it can be vulnerable to take judge one of the certificate, and the keys. We can maybe someone can generate a key and then use that and see that, okay, it can crack the thing. So that was the earlier one. The current standard is using these certificates, and even these certificates can be vulnerable in the case like if you have kind of digital signatures. You know about digital signatures and all, right? So you cannot it's like a hash function used there. You create one, and then the same thing cannot be generated with another key, right? So but there is a possibility like you can predict, you can try with different like a different supercomputer connected together, and you can generate the keys and see whether that fits to each device and try to connect. Yes, in that case it is possible, but that needs a huge investments, like you need to mine it and get it done. So that's a huge investment. So then the possibilities like you need to have more like length. And why we moved from SHA 256 to 512 means like more security is there. Like then it will be moving to more length and breadth for all the keys. So that's how it's.
Okay, so I guess we don't have any other questions. So now that was a very informative and engaging presentation. It's always a pleasure having you with us, Sidharth. Thank you for always being there with the department whenever we need you, be it when you come for a short vacation or even when you are abroad. I, on behalf of the entire department of CSE, would like to express my heartfelt gratitude to you for accepting our invitation and being a part of this FTP. Thank you so much.
It's been a great pleasure to work with existing my own like institution. So anytime it is my pleasure to come and deliver something on that. Like I can see that there is 78 people there right now. So thanks for this in this new normal method, and I would like to encourage this kind of webinars going forward, so that it will have a lot of like industry, what's currently been done in industries, like what is the standard they are using, that will like encourage the researchers also. Also as a faculty, they can also give a pathway for the students as well. So I hope that some light, I can put some light to anyone like on from how the industry works. That's very well. And also thanks for everyone for joining and hearing from me.
Thank you, Sidharth. If you could please stay back with us for 5 more minutes, it would be great.
No problem, ma'am.
Okay. So we have come to the end of the 5-day online FTP. A gentle reminder to the participants, please fill the feedback form, which will be posted soon in the chat. Certificates will only be sent to those who fill the feedback form. Another thing, we will be uploading the recorded sessions to the YouTube and will be sharing the link during the next week. Dear participants, please bear with us for 5 more minutes. We'll be happy if we could get some feedback from the participants. I would request some of you to please unmute your mic and give us a feedback. It would be great if it will definitely help us in improving ourselves whenever we conduct another such FTP or any other workshop. Can somebody please give us a feedback?
ഗുഡ് ആഫ്റ്റർനൂൺ. ഇത് റിനേതയാണ്, ലൂഡ്മാത കോളേജിൽ നിന്ന്. അപ്പൊ ഞാൻ ഈ സെഷൻ അറ്റൻഡ് ചെയ്തായിരുന്നു. ആക്ച്വലി നല്ലൊരു സെഷനായിരുന്നു. ഇന്നത്തെ മാത്രമല്ല, ഓവറോൾ പറയുകയാണെങ്കിൽ ഒരു പുതിയ കുറെ ടെക്നോളജി നമുക്ക് അറിയാൻ കഴിഞ്ഞു. പിന്നെ മാത്രമല്ല, കുറെ ഹാൻഡ്സ് ഓൺ പ്രസന്റ്, കുറെ ചിലതൊക്കെ ചെയ്ത് കാണിച്ചു തന്നു. അതേപോലെ തന്നെ പ്രസന്റേഷൻസും ഒക്കെ വളരെ ഇംപ്രസീവ് ആയിരുന്നു. ഇന്നത്തെ സെഷൻ പ്രത്യേകിച്ചും ഒരു IoT കുറിച്ച് ഒത്തിരി അറിയണമെന്ന് ആഗ്രഹം ഉണ്ടായിരുന്നു. അപ്പൊ എന്തായാലും വളരെയധികം താങ്ക്സ് ഇങ്ങനെ ഒരു സെഷൻ അറേഞ്ച് ചെയ്ത് തന്നതിൽ.
Thank you, ma'am. Thank you for the lovely words. Any other esteemed faculty member who would want us to give us a feedback?
Hello.
Hello, ma'am.
Hello, this is
Yeah, please go on,
this is
ma'am.
Hamil Stanley from Saraba Institute of Science and Technology. Yes, this 5-day program,
session with,
FTP program was such a we got really a lot of informations on, though we know a lot of things, but we are not experiencing it hands-on, right? So came to know a lot about cloud computing, about blockchain, about stuffs like that. So today's session was also very excellent, Siddharth sir. So I thank the college for arranging such a 5-day FDP program. I thank you once again.
Thank you. Thank you so much. Any other feedback or suggestions? Anything would be welcome. Okay, I guess that is it from the participants. Now, I would like to welcome our HOD, Dr. S.V. Anlin Jabba, for the valedictory address and tell us what her thoughts are on this 5-day online FTP. Welcome, ma'am.
Lakshmi Miss, can you hear me?
Yes, miss, please go on.
Okay. Good afternoon to one and all. So we have completed this 5 days FDP program. So throughout the session, I have just reviewed through all the sessions. So I am very thankful for all the participants for sincerely attending this program with a right spirit. And I hope that every session will be very useful to you so that you can learn a lot based on the emerging trends. And especially, I am very thankful to Sidharth. So the current session was handled by Sidharth. Thank you, Sidharth, for continuously keeping in touch with us, especially your college. Thank you very much for your sharing your valuable thoughts and your valuable time with us. Also, I am thankful for all the resource persons because they have shared their valuable, even though they are in the busy schedule, they have shared their valuable time and thoughts with us. And they have attended the sessions in correct time and completed that in correct time. So everything has gone in a smooth and it is well done. Once again, thanks for all the participants and the resource persons, and especially for the coordinators. So their effort is a very important one. So the coordinators, Lakshmi Miss, Saumya Miss, and behind this, some other faculties are also there. They have all the activities of the FDP program. Gobu sir, Arun sir was there behind the scene. So once again, I thank for each and everyone. And thank you.
Thank you, ma'am. It's now time to express our sincere gratitude to everyone involved with this 5-day online faculty development program. And I have one more role to do, that is to propose the vote of thanks. My words of gratitude first goes to the management of Sri Buddha College of Engineering for supporting us all through. Thank you. My words of sincere gratitude next goes to a person who is always a constant source of inspiration for all of us, Dr. S. Suresh Babu, the principal of SBCE, who also delivered the presidential address. It was his initiative that resulted in the organization of this FDP. Thank you, sir. We were privileged to have a very eminent personality amongst us for the inaugural session of this FDP. Someone I have always looked up to, Sri Santosh Kurup, CEO, ICT Academy of Kerala. My heartfelt gratitude to Santosh sir for being gracious enough to accept our invitation to be a part of this FTP and enlightening us with his talk on IR 4.0. I would like to express my sincere gratitude to all our resource persons, Mr. Adarsh S., who is also a very dear friend, Dr. Hiranvi Nath, Mr. Nitin Prince John, a student turned friend whom I am so proud of, Mr. Graham G., another alumnus of SBCE, Dr. Jesu Veda Nayahi, Mr. Jairaj VS, and a dear friend, Sidharth Rajeev, another alumnus of SBCE, who has scaled greater heights since then. Thank you all. My words of gratitude next goes to a person who is instrumental in organizing this FDP, our beloved HOD ma'am, Dr. S.V. Anlin Jabba, who also took a truly engaging session in this FDP. Thank you, ma'am. This would not be complete if I don't acknowledge the contributions of my colleagues in organizing this workshop, Ms. Saubhya Murali, Ms. Reshmi S, coordinators of this FDP. Actually, I am speaking on behalf of them too, but I know I don't need to thank them, but I really appreciate the efforts you have put in. Mr. Gobu Darshan, Assistant Professor, Department of CSE, for all the support and whose contributions needs a very, very special mention. Mr. Arun PS and all my other colleagues in the department, thank you all for the support. Now, no matter how well an FTP is organized, or no matter how many eminent personalities are there as resource persons, the success of an FTP always depends on the participants. And we were so delighted to have a bunch of active participants. So last, but not at all the least, our heartfelt gratitude to each and every one of you who registered for this FTP and attended it without fail. We really hope we made your time worthwhile. Thank you, each and every one of you, from the bottom of our hearts. Hoping to meet all of you in real at some other occasion. All the very best to all of you. And please stay safe and do take care of yourselves in these trying times. One more thing I forgot. I also wanted to acknowledge the contributions of Mr. Vishnu R, our system administrator, and the technical staff under him. So this is your host for the last 5 days, Lakshmi, signing off. Thank you, one and all.
Thank you, ma'am.
Thank you, Sidharth.
Thank you, ma'am.
Thank you, ma'am. Thank you. It was great having you here, Sidharth, once again.
It's my privilege, ma'am.
Thank you all.
Thank you.